multiply the first function by the derivative of the second, and add to it the second one by the derivative of the first one. So you have to derive, it's a bit like the chain rule, what we were doing. You derive after, keep one the same. So let's do this out. We can do it both ways, this one, so we can check our answers afterwards. So this says to do u times the derivative of second. Okay, so x minus 3x squared is the first function. Multiply by the derivative of the second one, v. So I just called u and v for two different names. What's the derivative of this one? 7x cubed minus 14 derivative? 21x squared, very good. Oh, not 20x squared. 21x squared. That's it. Plus the second one, which was 7x cubed minus 14 times the derivative of the other one.
1 minus 6x.
1 minus 6x, very good. Okay. Now, probably, if you had something like this, you could multiply it out and get a polynomial out of it. Might as well do that, just because we're going to check our answer in a second. X times this, 21x cubed. This times this, minus 63x4, isn't it? Do correct me if I'm wrong. 7x cubed minus, I'm multiplying this by that, minus 42x4. These two, minus 14. And these two, which is plus, quick maths, 6 times 14? 84, very good, yes. Okay, and any like terms, I think we would start off with negative. These two put together, which would be negative, not 60, negative 107x4.
107? What?
105, that's terrible, yes. I was looking at the 7 for some reason. And then these two, 28x cubed plus 84x minus 14. Okay, a bit of a nightmare because I made it up myself. Probably could have made. Could we have done that a different way? Yes, of course. For this one, let's just double check our answers. Is sure. Let's multiply first and use the, what's that rule called again, where you do them bit by bit, one at a time?
Expanding your brackets.
No, when you do the derivative bit. Power rule, very good. First principles is the long way. Yeah, you could do it using first principles, but you would be here all day. X5 minus plus 42x squared. Is that going to derive to that?
You just never know.
Well, I see 5 times 21 is 105, which is nice. So that's 28x3. Now I'm going to derive. So this is the original. Now we're looking at changing x over changing y. Minus 14 minus 105x4 plus 84x. Very good. Look, they are the same. Aren't we just? Okay, so the product rule works. That's just, that's not a proof. It's just, what is it? Proof by one example, I suppose. Not proof.
How would you have to prove that?
There is a way of proving it, yeah. But we're not going to do it. You'd have to use lots of variables. This then, a lot more likely, where you have to use the chain rule within the product rule, because you don't want to have to multiply everything out. So let's look at an example like that. Which one looks worse?
The second one.
Second one looks worse. First one looks bad because it's got a square root in it, though.
That's like
Yeah, you guys not very good with the square roots from the starter, so let's have a little look. No shade.
Is that like a call out to someone?
A call out to someone?
Yeah. Like a direct call out?
No, I didn't even see yours.
No, I'm like general question.
Oh, no. Okay, this is you, and this is V. Right, so let's go. The derivative will be u, the first one. Very good, that's easy. Root x times whatever the derivative of this is, and this is where we have to use chain rule. What is the derivative of this?
2.
No. Bad start.
3.
3. 2x plus 1
Oh,
power
okay.
2. Anything else?
And then 2.
Multiply by 2, yes. Okay. So that's the derivative of v. Some people call this, if you ever see v dash, and this is u. Sometimes u, v dash, you see use dashes.
The inverse.
Not inverse, dash stands for first derivative. If that was a -1, then we'd have inverse, yes. And the second one then is 2x plus 1 cubed, which is just v, times the derivative of this, which is, quickly,
X to the 1 over 2.
all right,
Half.
x to the half, multiplied down by a half. So tidied up, it would be
Wait.
1 over 2 root x.
Oh, goodness.
Oh, hell.
Does that make sense?
Yeah.
So the power, it'll bring it down with the 2. Okay. Now this is, you could tidy this up a little bit. This is u dash, not u1, u dash. Tidy it up a little bit, like the 2 and the 3 and the root x would make 6 root x. And then 2x plus 1 squared. Usually there's a follow-up bit to this question where you'd have to sub in, find the gradient at a certain point. I would just leave it like this and go, right, what's the next part of the question? So I just multiplied the little easy bits I could. All right. So usually it's now sub in something to get the gradient.